All right, this is part 2 of the density calculation examples. The second question says, what is the mass of a 25.5 milliliter sample of water? The density of water is 0.998 grams per milliliter. All right, so we know we are working with a density problem, so let's start by writing down what variables we'll be dealing with. Okay, so if we look back at the problem, I see 25.5 milliliters. Milliliters is a measure of volume, so I know that that is V. Okay. Next piece of information that is given to us is 0.998 grams per milliliter. Grams per milliliter, so mass per unit volume. Also notice that the question does say it is the density of water. So I will write down that volume for D. Okay. Notice the question did say, what is the mass? So the mass is unknown. All right, we will be using the equation D equals M over V. Just like before, we're going to plug in our values. So if you are not comfortable with doing the calculations with the units in the problem, then you need to know how to figure out what units you'll end up with. So let's look at the density. Okay, grams per milliliter. Okay, that's mass per unit volume. So we know that our units will be grams. Okay, that's the mass unit that you find in the density constant. So let's plug that in. We have 0.998 grams per milliliter equals mass over 25.5 milliliters. Okay, so I have a fraction on this side. I don't have a fraction on this side. So let's turn this side into a fraction so we can do some easy algebra. Okay, so 0.998 over 1. Okay, milliliters is next to it because it was on the bottom. It's the bottom unit of the given. Okay, so grams per milliliter, it automatically goes into the denominator. All right, so we're going to cross multiply 1 milliliter times M. Okay, it might be easiest to write the numbers in parentheses. That's the way you keep everything straight. Keeps you from confusing units with variables. Okay, so M is our variable, not our unit. Milliliters is the unit. Okay, 0.998. Let me punch this into my calculator. 0.998 times 25.5. Okay, just to be correct here, let's go ahead and report this multiplication in the correct number of significant figures. So 25.5 has 1, 2, 3 sig figs. 0.998 has 1, 2, 3 sig figs. So I should report my answer with 3 significant figures. So when I punch that in, I got 25.449. Okay, if I'm looking for 3 significant figures, I'm looking at the fourth number. Okay, the fourth number is 4. Okay, because it's not 5 or greater, we are going to round down. So 1 milliliter times M equals 25.4 grams times milliliters. Okay, so since I multiplied grams times milliliters, my unit is grams times milliliters. Now, I see that I have milliliters on this side of the equation, and I also have milliliters on this side of the equation, so they will cancel out. Mass equals 25.4 grams. Okay, we already figured out the correct number of significant figures. The given information gave us 3 sig figs, 3 sig figs, so our answer has 3 significant figures. Okay, and then again, our unit is grams. You can either solve algebraically, as I did in this example, or you would know it by looking at the mass unit for density.